Okay, so we're looking at page 18. And we are looking at exponential equations first. Alright, so exponential equations are equations that have indices. So let's have a look at some. Alright, x squared is equal to 4. So what number do I square? And the result is 4. 2? Just 2? Negative 2, okay? Remember, negative 2 times negative 2 will also give you that positive 4. So, to solve, we take the square root of both sides, okay? But when we take the square root, you need to include that as well, plus or minus out the front, okay? So, plus, minus the square root of 4. So, you take the square root, and then you take both the positive and the negative component of the answer. So, x equals plus or minus 2. There are two possible solutions in most cases when you have a quadratic. Okay, I mean the power of 2 is the highest power. Alright, b 2 to the power of x equals 64. So one of two ways you can do this. One, you can do trial and error. Okay, 2 to what power equals 64? Okay. Or you set it up as follows. 2 to the x is equal to, because 64 is the result of 2 to the power of, you've got 2, 4, 8, 16, 32, 64. So 2 to the power of 6 equals 64. Okay, it's doubling each time. Okay, so when the bases are the same, the index must also equal the same. Alright, so x must be 6. Alright, c to the power of 3 over 4 is equal to 16. Alright, remember our indices laws. So we've got a m to the power of a over b is going to equal a root. Okay, the base goes inside the root. The numerator stays with the base, so it'll be a, and then the root power, which is the denominator, goes out the front. Okay, so we did that in indices. Alright, so what we need to do is get c by itself. If I get c to the power of 1, I've achieved that. Okay, so what do I need to multiply by 3/4 to give me 1? So 3/4 times what equals 1? 3/4 times 3/4 will give me 9 over 16. Okay. 3/4 is 12, 9. 3/4 times a third will give me 1 over 4. Okay. Yeah, which will give me 1 over 4. Good. Alright, so if I do 3/4 times 4 over 3, that way I can cancel, equals 1. Got there. Good. Alright, so that means c to the power of 3/4 or to the power of 4 over 3. Okay, so what I want this to be cancelled to give me 1. So I must also do it the same on the right hand side. 16 to the power of 4 over 3. Okay, that is how you solve these equations. So these will cancel the whole thing because you're multiplying opposites on top and bottom, vice versa. So c is going to be 16 to the power of 4 over 3. So this is where you go to calculators. Make sure you put a fraction in as your power. or you use your root laws, okay? So 16 to the power of 4 over 3. So we put the root when there's a fraction, 16, the numerator goes with the base, the denominator becomes the root power. Alright, but you should all be able to go to calculator. 16, you need to put a fraction when you put the indices. Okay, so 16, push your power button, and then you need to push the fraction. Okay, 4, 3. Huh. Must have had a typo on my notes. Alright, 40.3174. 7. Okay, this is an example of where the question had not asked you specifically to write in a certain number of decimal places. Alright, so if that's the case, you will leave it as third form or index form. Alright, so your final answer will be c to the power of 16, c to 16, 4 over, okay, because you have not been told to do an approximation. Okay? So you only round if you are told to. Okay? If it has not told you to round, you'd leave it as thirds, indices, whatever, simplified down to simplest form. Okay? And that will do for that answer there. Alright, D. 6 to the power of 4k plus 1 is equal to 216. Alright, to solve for k in an index, okay, we need to have both sides with the same base. Alright, so 6 to the power of what gives me 216? Okay, 6 to the power of 3 gives me 216.
Whoa, what a guess.
Educated guess, wasn't it?
Yeah.
You know, you should know 6 squared does not work. Right, so when you have the same base, you can then match your indices. So therefore, 4k plus 1 equals 3. Okay, same base, same index. Right, then you have a simple two-step equation to solve. 2 over 4, which simplifies to half. You need to express every single fraction you do in simplest form unless told otherwise. Okay? That is a generic rule for your whole course. Alright, question? Alright, that's 3.6 covered. Right, next one. 3 points. So we're now looking at quadratic equation. So Robin's had an example this morning already of a quadratic equation he needed to solve. And I'm sure all your extension students would have had at least one of these somewhere along the track. Okay, so there will often be two solutions. Not always, but often two solutions. There can be zero solution. There can also be only one solution. And we'll look at the significance of that in the future. Right, examples. Solve. Right, x squared, take away 7x, take away 18, equals 0. So the first method we're looking at is factorisation. Okay, so you all should be able to factorise the quadratic using your rules. Two numbers add to give, multiply to give negative 18. Same two numbers add to give negative 7. Okay, so negative 9 positive 2 is equal to 0. Okay, so when you factorise, you then have the setup for your solution. So, what this means, x take away 9 is 0, or x plus 2 equals 0. Because if any of these expressions in the bracket is equal to 0, and we multiply whatever the other number happened to be, okay, you'll get the result of 0 as long as one of them is 0. Okay? So you have two simple equations to solve there. X equals 9 and x equals negative 2. Okay, so you know we've covered how to factorise. It's now taking it to the next step. Alright, B. 2x squared plus x take away 6 equals 0. Now there are some people in this room that are doing their answers in one line, which is a bit surprising considering I do the working here. So if you've got a process that you're getting the answers, that's fine. However, I feel the need, I need to show the working. Right, so remember there's two ways you can do it. Okay. So I need two numbers multiplied to give 2 times minus 6, which is negative 12. Same two numbers add to give positive 1. So, time to give negative 12 and add to give 1. What are my two numbers? 4 and negative 3. Right, so that means equals, so I'm doing this my way because I like my way. 2x, add 4, sorry. 2x plus, sorry, take away. Plus 2x take away 3 over 2 equals 0. Some people like splitting up the middle term, that's fine. I'll do that in a moment. Alright, at this point you have to factorise, yep. Pardon? Right, so you factorise the 2 out of here, so you're left with an x plus 2. Once you factorise the 2 out of here, you're left with the 2 on the bottom. So x plus 2. Can't factorise that second bracket. 2's cancel. So you have an x plus 2. Whoop, this equals 0. So the equal sign should not be there at the start, because you already got an equal sign in the equation. X plus 2, 2x take away 3 is equal to 0. Right, so we've already covered this skill in the algebra section. So x plus 2 must equal 0. So x equals negative 2. 2x negative take away 3 equals 0. 2x equals 3. After we move that to the other side, we will have 2x take away 3 equals 0. 2x equals 3. X equals 3 over 2. Is anyone actually doing it in this method? Prefer doing it in this method? No. Nobody?
No one. Look at it. Why? Why would you do that?
Fine, I'll do it the other way.
Thank you.
Alright, 2x squared plus 4x, take away 3x, take away 6 equals 0. Some people have got to be really careful about their signs. That's why I like doing it my way, because it takes care of the signs. Alright, so let's factorise first two terms. Okay, so I'm going to group the first two terms together, and then I'm going to group the second two terms together. So, I've got a common factor of 2x in both those terms there. So 2x outside of x plus 2. I'm going to take the negative out, so negative 3x. Now, negative 3 times what? Gives me negative 6. Positive 2. Okay, some people in here are not being careful with their sign. Alright, so x plus 2, 2x take away 3 equals 0, and like above. The rest follows as above. Alright, so we've already done that, I'm not going to do it again. Okay, so it's an extra step, what you're doing in your equation, your algebra, by setting up as an equation. Right, is there any questions on the process? Any questions in general? Let's see, 2x squared equals x. Right, how am I going to solve this one? Suggestion. Pardon?
That'll help me.
Yes.
Let's solve it, please.
Say it again, sorry.
So we try and get all the x's onto one side.
Good, okay. This is what you do not do. Okay, you do not divide both sides by x. If you divide both sides by x, what you do, when you do a division of the variable, you actually eliminate one of your solutions. Okay? If you are dividing by the variable, you are eliminating one of your variables. So, do not divide by. Pardon? Yes. So you will never divide when you have something like this.
Hey, I didn't do it, Robin did.
Wait.
Make a note of that in your theory, please, because I do not want to see anyone going ahead and doing division. If you do a division, you eliminate one of your solution. Okay? So you need to do what Michaela's suggested. 2x squared, take away x, move it all to one side, set it equal to 0. Okay? And then you do your factorising. Right, so you've got x, 2x take away 1 equals 0. Right, so the term out the front must equal 0. And then the 2x take away 1 equals 0. 2x minus 1 equals 0. 2x is 1, x is a half. Okay, if you want to go straight from this line to the answer there, that's fine. Okay, I'm just showing you how it comes about. If you're not sure, I struggled with this when I was in year 11. Guess what my teacher told me? Show you working.
I can do it.
Okay, so now I can do it in my head. Okay, question? Alright, get the next one done, so you've got all lesson tomorrow to get some work done. Okay. Next one. So that was 3.7. 3.7. Okay, the next one. So, not all examples like that you will be able to factorise. So we need to look at other methods. Remember when we did completing a square in algebra? That's why we did it then, because you're going to apply it for these following questions here. Alright, E. So you're going to solve by completing the square. Not the first one necessarily. So x squared equals 11. So we had an example already similar to this. I don't know where I've got this here. I'm not going to go through all that completing the square stuff. So x is going to be plus or minus the square root of 11. If you do not show that there are two possible solutions, you will not get your full marks. Okay? Now that I'm showing you, that's what you're going to be expecting. Yep. So?
Did you already do D?
You skipped D. You went from
D?
D.
Oh, no I didn't. Right. Okay, so go back to D. So that's the final solution for E. Okay, I cannot simplify that third any further. Okay, I'm not asked to do any approximation. But that's your final answer. Okay. Right. Sorry, Nathan. We'll go back to D. So x plus 3 all squared is equal to 25. Okay, what would be the first thing you do here? Take the square root because I have a square number on this side. So x plus 3 is going to be plus or minus the square root of 25. The x plus 3 is going to be plus or minus 5. Okay, there are two possible solutions you need to consider. Right, so x plus 3 equals 5, the positive component. X plus 3 equals negative 5, the negative component. Alright, you don't need to show you're working for simple one-step equation. Alright, so 5 take away 3, which is 2. And then a negative 5 take away 3 for the other equation. Negative 8. Okay, so 2 plus 3 is 5. 5 squared is 25. Negative 8 plus 3, which is negative 5. Negative 5 all squared is also 25. Okay, so when you do quadratics, when you're solving equations involving quadratic, you can expect two solutions most of the time. Right, carry on from where we're doing. F. The first couple are not completing the square. Anyway, x plus 4 all squared equals 5. Right, so we've got a similar sort of thing. However, the 5 is not a square number. Okay, so you're not asked to approximate either. That means you're going to leave it in third form. Right, so if you take the square root of both sides, right, plus or minus this side, so x plus 4 is going to be plus or minus root 5. Okay, I cannot simplify that any further. So that means x plus 4 is equal to the positive component, which is root 5, and x plus 4 also equals the negative component, negative root 5. Okay, so x is going to be root 5 take away 4. That cannot be simplified any further. Okay, root 5 will give you an irrational number. And then x is also negative root 5 take away 4. Again, you cannot simplify that down any further, so you will leave it there as it is. Okay, so the first couple there were not completing the square, the next ones will be. Any questions before I move it on? Is everyone following what's happening? Everyone getting some sort of understanding? Yep. All right. G. X squared plus 6x is equal to 7. Right, so this is the process of completing the square. So back in your algebra section, we had to complete the square on just the x squared plus 6x. Right, so completing the square, we half the coefficient, and we squared the result. So it'll be x squared plus 6x plus 6, which is the coefficient of the x term. We're going to half it, and then we're going to square the result. Okay? So x squared plus 6x, 6 divided by 2 is 3, 3 squared is 9. And then we factorise. So the result will be in x plus 3 all squared. Okay, similar sort of setup. So, x squared plus 6x plus 6 over 2 all squared. Now, because this one you have an equation, watching, little guy? Watching? Because this one's an equation, what I've included on this side, I must also include on the other side, okay, to balance the equation. Right, so x squared plus 6x plus 9 is going to be 7 plus 9. So I'm adding 9 to both sides of the equation. It is still a balanced equation because I'm still doing the same thing to both sides of the equal sign. Okay, let's factorise this. This is now a perfect square. It's two numbers multiplied to give 9, same two numbers added to give 6. Okay, 3 times 3, 3 plus 3. It'll be x plus 3. Because the same number, we write it as x plus 3 all squared. 7 plus 9, 16. Alright, so we've seen some examples how to solve this. Back up the top there. Alright, so x plus 3 is going to be plus or minus the square root of 16. So, plus 116. So, x plus 3 must equal the positive square root, which is 4. X plus 3 also can equal the negative component of negative 4. So x equals 4 take away 3. X equals negative 4 take away 3. There's our two possible solutions. H x squared plus 8x plus 9 equals 0. Okay, so you're told specifically you need to complete the square as part of the question. Because there's no two numbers multiplied to give 9, same two numbers add to give 8. Okay, because both numbers need to be positive or negative, because there's a positive result when you multiply, and there's no way you can get two numbers to add to give 8. Because the only way you can do it is 9 times negative 1, but you've got negative answers there, positive answers there. Alright, so step number 1, so x squared plus 8x is equal to, move the constant term on the other side. Okay, so x squared plus 8x. So you need to complete the square on the left-hand side. So you need half the coefficient of x and then square it. So 8 over 2, square the result. And because I've added it to the left-hand side of the equal sign, I need to do the same to the right-hand side. Minus 9 plus an 8 over 2 all squared. Okay, so I've included those on both sides. X squared plus 8x. 8 divided by 2 is 4. 4 squared is 16. Is equal to negative 9 plus 16. Okay, so on both sides I've included another 16. Alright, two numbers multiplied to give 16, same two numbers add to give 8. 4 and 4. Okay, it's the same number. So x plus 4 all squared. The negative 9 plus 16, which is the same as 16 take away 9. 9, we've got 7. And this is why we complete the square, because there's no way we can factorise it up the original step. So x plus 4 is going to be plus or minus root 7. Take the square root of both sides. So x plus 4 equals root 7. X plus 4 equals negative root 7. Okay, quadratic, you have two solutions. But people okay with me doing another two? Yep? Oh, well, I'll get that done. So our next lesson, which will possibly be Monday now, we'll be moving on to the next section. Right, I. X squared is equal to 4x plus 3. Okay, so again you're told specifically you need to solve by completing the square. So I need the x squared and the 4x on one side, and I'm going to leave the 3 on the other side. X squared, move the 4x over, change the sign, and that's how we're going to complete the square. X squared, take away 4x, it'll always be positive, that third term. Right, so we halve the coefficient, and we square it, and we do the same to the other side. Okay, if you want to just write the number straight away, that'll be fine with me as well. This is what I personally do, but I'm teaching this for the first time, so I am going more step by step. Right, so 4 divided by 2 is 2, 2 squared is 4. Okay, if you want to go straight from this line to that line, that's fine. If you set it up correctly, it'll always be a perfect square. That means same two numbers multiplied to give 4, same two numbers add to give negative 4. Okay? So x take away 2, or squared, is equal to 4 plus 3, which is 7. Completing the square will require a third as part of your answer, majority of times. Right, x take away 2 is plus or minus root 7. So when you take a square root, you need to have the plus or minus component. We'll look at some cases later on in your course where we're only considering either the positive or negative square root. That'll come up when it comes up. So x take away 2 is square root of 7, and x take away 2 is negative square root. Negative square root of 7. So x is going to be root 7 plus 2, and x is also going to be negative root 7 plus 2. Okay, if you want to prefer to write it like that, that's fine. Okay, last one. Bit of work to do. X squared take away 13x is equal to 28. Okay, so when you're asked to complete the square, you need all your x terms on one side, including your squares, and all the constant terms on the right hand side. So, x squared take away 13x plus 13 over 2 all squared. Now the 13 over 2 doesn't simplify, so we're going to have a fraction when we square it is equal to 28 plus 13 on 2 all squared. Okay, I'm not going to square the result just yet. Okay, because the other thing you can recognise, if you've got the perfect square at the end and you've got double in the middle, okay, so double this is just 13 with the minus sign. So x take away 13, should be half that coefficient. So 13 on 2 all squared. That's right. Yep. Okay, so that and that with the square at the end. It's going to be 28 plus 13 on 2 all squared. I'm going to leave it like that because when I do the square you'll get a fraction. Okay, so it's not going to benefit me anymore right now. Actually, yeah, it might be easy if you guys see it as a whole number. Alright, so what is 28 plus 13 on 2 all squared? And 81 and 4. Okay, leave the fraction. Alright, so x take away 13 on 2 is going to be plus or minus square root of 281 on 4. Nope. Okay, which equals plus or minus the square root of 281 on 2, okay? Because I've taken the square root of 4, so always simplify thirds to simplest form. Alright, so x is going to be square root of 281 on 2 plus 13 on 2. X is also going to be negative square root of 281 on 2 plus 13 on 2. Okay, so that will be final answer. Okay, if you really wanted to, you could do square root of 281 plus 13 all over 2. But the skill is the setting up, completing the square, not putting the fractions over a common denominator. Okay. Right, a bit to get through today. Thank you for letting me do that. That way you'll have some time tomorrow. Get your chapter 2, 3.8. Okay, so chapter 2, you have plenty of time to get that all done now. Robin's happy you're finished.
We need help. All of help. Heaps of help.